Question 1.84. Two balls have the same mass and the same charge, 15.71 microcoulomb. They hang from the ceiling on strings of identical length L equals 1.223 meter. The angle of the string with respect to vertical is 21.07 degree. What is the mass of each ball? So here we have two identical balls with same mass. Let me call this ball 1 and ball 2. And they have the same charge Q, which is 15.71 microcoulomb. Microcoulomb we can write as 15.71 times 10 to the power negative 6 coulomb. And they are suspended with the help of a string which has a length L equals 1.223 meter. And the angle the string makes with the vertical is theta, which is 21.07 degree. We need to find the mass m for each ball. To find the mass, we need to first identify the forces acting on these balls. And since they are identical, we can only find force on one ball, and that is enough to calculate the mass m. So let us start by identifying all the forces acting on ball 1. The first force that we take into consideration is the force due to gravity Fg, and this force always acts vertically down. Then we have the force of electrostatic repulsion between ball 1 and 2. Since they both have the same charge and both of them are positive, they will repel each other with force Fe. Then you have the tension in the string that points towards the suspension point, so tension T. So these are all the forces acting on mass 1. Here, Fg and Fe lies on the y and x axis respectively, but the force of tension lies neither on the x-axis nor on the y-axis. So we have to split this force into its component. One component that goes along the y-axis, we call it dy, and the other component that goes along the x-axis, we call it dx. Now to calculate the mass m, we will write the equation of net force along y and x-axis. So let us start along y-axis. Both the balls are at rest. And if an object is at rest, the net force acting on the object will be 0. So net force along y-axis, F net y, will be equal to 0. There are two forces along y-axis, Ty and Fg. And according to convention, all forces which are acting upward, we take them positive, and the force which are going down, we take them as negative. So we write Ty positive and Fg negative equal to 0. Rearrange them and we get the tension along y-axis to be equal to Fg. Ty I can write as T cosine theta. Cosine because Ty is the side which is adjacent to the angle theta. And any side which is adjacent to the angle theta, we associate that side with cosine. Fg is equal to mg. So I can write T to be equal to mg over cosine theta. Let me call this equation 1. Now we do the same thing along x-axis. Again, net force along x-axis will be equal to 0. There are two forces here, force of tension along x-axis and the electrostatic force of repulsion between them. Tension is going to the right, so by convention we take it positive, and Fe going to the left, we will take it negative. So we write Tx minus Fe equals 0 or Tx equals Fe. Tension along x-axis is T sine theta. T sine theta because it is a side which is away from the angle theta. So we associate that with sine. Fe is the electrostatic force, which you can write as K Q1, Q2 over the distance between them squared. Distance between ball 1 and 2 is T, so we will take T squared. And when you rearrange this, you can write T to be equal to K. Since both ball 1 and 2 have the same charge Q, instead of writing Q1, Q2, I can write them as Q squared over T squared and divide by sine theta here. This is my equation 2. Now both equation 1 and equation 2 are equal to the tension in the string. So if the left-hand side of an equation are equal, the right-hand side will be equal to each other as well. So we write equation 1 to be equal to equation 2. And let's equate their right-hand side. For equation 1, we have mg over cosine theta. And equation 2, we have kq squared over d squared sine theta. We want to find the mass m, so let's rearrange the term. I'm going to multiply with cosine theta and divide with g. We get m to be equal to kq squared cosine theta over d squared g sine theta. Now this is the expression for calculating the mass. I know every term over here except the value of t. We have to calculate t from the figure given here. So let's redraw our figure. You have the two strings in this manner, and then you have the two balls. Separation between them is d. So this is my distance d. Let's draw an angle bisector. When you draw an angle bisector, this is the angle theta here as shown in the figure. And this angle bisector is going to divide the length d into two equal parts. So I can write this as d by 2 and d by 2. This is the length L of the string. Now from the figure we can notice the angle theta is opposite to the side d by 2. And if you have an opposite side, I can relate that to theta using sine of the angle theta. We know that sine theta is equal to opposite over the hypotenuse. Opposite side here is d by 2. Hypotenuse is the length of the string. So I can write d to be equal to 2L sine theta. So let's substitute this in our expression for mass here. I will rewrite the mass m as kq squared cosine theta. In place of d, we will write 2L sine theta squared g times sine theta. Now let's substitute everything to find mass m. K is the Coulomb constant, which is 9 times 10 to the power 9. Q is 15.71 microcoulomb squared. Cosine, the angle is 21.07 over 2 times L, which is 1.223 into sine of the angle theta, 21.07, and square of the whole term into G, which is 9.81, and again sine of the angle 21.07. And when you solve this, you get the mass m to be equal to 0.76 kilogram. So to solve this question, you can also use shift solve at this step over here if you do not wish to rearrange. But before using shift solve, you still have to find the value of t. So once you arrive here, you can find what is t, which is 2L sine theta. Substitute this in place of t, and then you can use shift solve to arrive at the same answer.